scholarship test for ESE and GATE stand a chance to win for a scholarship pool of 50 lakhs. Register for free today.
Welcome dear students. Good evening, good evening, good evening. Very welcome to the Gradeup, the India's largest e-learning platform, dear students. Hi Prem, how are you? Come on, join the session very fast. Come on, join the session. Giriraj Singh, very good evening. Come on, Giriraj, welcome. Prem, welcome. So, dear students, this is the session which is the part 2 of the yesterday's session. Dear students, we started with the questions on the bulk deformation, and in the today's session, we will be looking for some questions on the sheet metal working. So, this is the second part. Yesterday, we have seen some questions. Right? Yes, come on, join the session. So, dear students, please share this session, like this session, ask your friends to join this session. Today also we are going to discuss some of the nice questions based on this topic, metal forming and sheet metal working. Sri Kumar, good evening Sri Kumar. Chalo aa jao and be there till the end of this session. Be there till the end of the session, dear students. It is very helpful. Okay, it is very helpful. Don't leave it. So shall we start? So dear students, this is about me. I am Onkar. Kalpana, very good evening. I am Onkar, having more than 10 years of experience for teaching GATE and ESE. Till now, I have mentored more than 10,000 number of students for GATE and ESE, and my area of expertise or the area of interests are production and industrial engineering, fluid mechanics as well. So, as you know, dear students, there is a GNST examination which is on December 19th. Yesterday also I told you to register. There is a free registration for this GNST that is Gradeup National Scholarship Test. Okay, there is a scholarship pool of 50 lakh. So Sri Kumar, if you missed it, yesterday's session there is available on YouTube. If you look at that, no any big deal. Definitely Sri Kumar, definitely. I will plan for those sessions also for industrial engineering. Okay, so please dear students, you can see here the schedule, timings, the important dates, times in this slide. Stage 1 which is on 19th December and stage 2 which is on 21st December. The timings are here, test duration, the timings, result date, all are here. Also there is a syllabus, some important information, question distribution, all the things are here. Okay, so do register for this test which is on 19th of December and try to avail the scholarship dear. Right? So yesterday actually we were having 2 questions which I had given for the homework. How many of you solved these 2 questions? So some of you said that sir, you just carry out these 2 questions in the today's session. So come on, take this question, very important. That's why I have taken for this session these 2 questions from the yesterday's practice session which is on the extrusion. This is the first question on extrusion, and again the second question is also on the extrusion. So let us solve this question. Let us solve this question. A cylindrical billet of 50 mm diameter and 100 mm length is extruded to a final diameter 25 mm by using the direct extrusion. Okay, you know the direct extrusion, how it is done. If this is a rigid wall container and there is a die, okay, which is having the included angle which is given as say 90 degree it is given. So of course I have to show some space, orifice to. Okay, so suppose it is here like this and you are getting the product here. This is the ram, this is the ram, and say this is the billet. Okay, so now here the billet material, cylindrical billet having the 50 mm diameter. So diameter is given. So diameter is given. How much diameter? 50 mm. So diameter is given 50 mm. And the length of the billet is how much? Actually it is 100 mm. So definitely there will be the container shear stress is going to come into the picture, which they are saying that by using the Tresca's condition to take the value of the maximum pressure due to the container wall friction. Okay, that is tau we need, because we know that because of the container wall frictional, the frictional force or the frictional stress that we have to calculate, that will be equal to 4 tau L divided by D, isn't it? Or D naught, original diameter of the billet. For that they are saying using the Tresca's criteria, you take that maximum pressure due to container wall friction. So how much it is the tensile yield strength? It is 120 megapascal. Definitely by using the Tresca's criteria, this tau will be equal to this sigma y by 2, which will be 120 divided by 2. That will be how much? 60 megapascal. 60 megapascal, that will be the frictional stress. Okay, frictional shear stress on the wall container we have to take into account, which is other than the drawing stress sigma d, isn't it? So tell me, yes. So सबसे पहले क्या करना पड़ेगा हमको? So original area is how much? Or original diameter of the billet, D original I will write here, D original 50 mm. D final, what is the product diameter? Final diameter cross section, okay, to a final diameter 25 mm. Okay, then what they are saying, the sigma y or sigma flow is given, the die angle is 90 degree, of course that is alpha, you have to take it as 45 degree. Okay, and the coefficient of friction mu is 0.1. So tell me what is B? B is equal to mu cot alpha. Mu is how much? 0.1 cot of 45. So tell me what is B? Tell me what is B value? So and then the drawing stress, you know, sigma d is equal to sigma y into bracket 1 plus b divided by b into what? R to the power mu cot alpha minus 1. This is for the extrusion, that you know very well. Yes or no? So here R is what? Extrusion ratio. Tell me what is this 0.1 divided by tan 45. It is 0.1. Okay, sigma y is how much? 120 megapascal. So extrusion ratio is how much? R extrusion ratio, which is equal to ln of A original by A final. This is the extrusion ratio, isn't it? Sorry. Extrusion ratio, it is A original by A final, which is equal to what? A original is how much? Pi by 4. Diameter original 50. That is 50 by 25 whole square. Pi by 4 get cancel out. Anybody is there to calculate the values? Be there for the calculation. So R is how much? 2 square, that is R is equal to 4. Extrusion ratio R is equal to 4. Okay, now tell me, I can write here now sigma d is equal to sigma y is 120 into bracket 1 plus b is how much? 0.1 divided by b 0.1 into bracket R 4 to the power b is what? Mu cot alpha is what? B to the power 0.1 minus Okay, minus 1 into 1.1 divided by 0.1 into 1. So check it out whether it is 196.28 megapascal. Have you got this value for the sigma d? Have you got value for the sigma d? Yes, come on dear student, join the session. Very, very important. It is very helpful to you only. Make it practice here. Because very nice. This is the extrusion ratio R you have got. Now tell me, yes, Sri Kumar. Very good, Sri Kumar. It is 196.28. Very good, very good. 196.28 aa gaya bhai. Now what is the next thing? Next thing is that the total stress, because what they are saying, the total drawing stress, if I want this, then I have to add here this sigma d plus this sigma frictional, because of what? Container wall friction is given and that resistance is given there, and for that they have saying that Tresca's condition to take the value of maximum pressure due to the container wall friction. That was how much? This tau is equal to, sorry, this sigma f is equal to 4 tau L divided by d naught, where tau by the Tresca's criteria we can take sigma y by 2, isn't it? By the Tresca's condition, this is 0.5 times of sigma y. So definitely it is 60 megapascal. So calculate the frictional force, the sigma frictional stress on the container wall. It is sigma f, sigma frictional is equal to 4 tau. This L is length of the billet divided by d original, which is the diameter of billet. So tell me, 4 into tau is how much? 60 into length of the billet is how much? 100 millimeter divided by diameter is how much? 50 millimeter. So how much the sigma f? 240 into 100 divided by 50. So it will be 480 megapascal. So sigma f, please check it out, please check it out, right? So what is 677? Okay. Now tell me, if this is the sigma f, now what is total sigma t? That will be, this is 196.28 plus 480 plus 196.28. It will be 677. Very good. 676.28 megapascal. Very good. Very good. Okay. So ये आ गया total stress because of the friction at the container wall and the drawing stress. Totality में total drawing stress was how much? 676.28 megapascal. Now that is the next thing is very easy. What they are asking? Find out the extrusion load in meganewton. They are asking the extrusion load in meganewton. How to calculate load? Therefore force is equal to this sigma total, okay, into which area? Now we have to take original or final. It will take the original in case of the extrusion and final area in case of the wire drawing. So sigma total is what? 676.28 into original area of the original cross section area of the billet. कितना है भाई? Pi by 4. diameter कितना है? 50 square, isn't it? So tell me, into 0.25 pi into 50 into 50, how much it is? 1.7 meganewton. 1.7 meganewton. Please check it out. What is this force? Tell me the answer. 1.7. Have you got 1.7 meganewton? Yes, come on. Kalpana, Sri Kumar, Vikas, and there are so many people. Please come on, join and participate. Participate in this session. Don't leave the session. Please be there. .7 meganewton. Please check it out. Kalpana, Vikas. 1.32, that is correct. 1.32 is coming. 1.32. Anybody is there? So Sri Kumar, that is very correct answer. 1.32 meganewton. That is absolutely correct. Please check out 1.32. I hope 1.32. 1.32, that is correct. Please check it out. 1.32 is simply, you can have the values here, just do the calculation and whatever the answer you will get here in meganewton you can write. Shall we go for the next question? Shall we go for the next? Yes, next question. This was the next question, yesterday's homework. So dear students, cylindrical billet of 90 mm diameter, D original was how much? 90 mm. Okay, and extruded to the I section as shown. This is the I section. Okay, this is the I section. All the things, all the dimensions are given. So what is the original area? That is of course pi by 4 D original square, and final area you are getting in terms of the I section. So what is cross section area of this I section? So it will be 50 into 5 plus 60 into 5 and plus again 50 into 5. So it will be 2 times 250 plus 300. How much it is? 500 plus 300, that will be 800 mm square. Okay, because all the dimensions are in mm. Original area is how much? Pi by 4. The billet area cross section, that is 90 mm, diameter 90 mm. So 90 square into pi divided by 4. So original area is how much? You are getting as 6361.72 mm square. Okay, and then if I calculate the extrusion ratio R, okay, or the ratio, that is A original by A final, that is nothing but what? How much? A original by A final. R is nothing but A original by A final extrusion ratio. A original is how much? 6361.72 divided by A final is how much? 800. It will be 7.95. This is our extrusion ratio. And what they are saying, this is according to the Johnson's rule. This is according to the Johnson's rule. They have given the extrusion pressure PE is equal to what? PE is equal to, this is actually sigma m into bracket A plus B ln of R. So this is actually the standard formula by the Johnson's equation, where A and B are the constants. Okay, where they are already given the things, and sigma and mean flow stress is also given, is how much? It is 80 megapascal. So I will write 80 into bracket A is how much? It is already given 0.8 plus B 1.2 into ln of R, we calculated here 7.95. Okay, so ln of this answer into 1.2 plus 0.8 into 80. So I am getting here the extrusion or pressure or drawing stress as 263.05 megapascal. And what they are asking? So they are asking the load in kilonewton, okay, to extrude this I section. So definitely it will be what? The load F is equal to this PE, that is our drawing stress, into original cross sectional area. So P is how much? It is 263.05 into original area we already calculated, it is 6361.72. 6361.72. It will be how much? it will be 1.67 meganewton. Okay, the load will be how much? 1.67 meganewton, or they are asking in the kilonewton, so it will be 1673.45 kilonewton. I hope it is very easy. I hope it is clear. 1.6, Sri Kumar, yes, 1.67 meganewton, that is correct. Yes, dear students, who is there? Who is there? Please participate. Don't just see it. Please be the part of this session. Have the calculators in the hand and do the calculation. Understand the numerical, do the calculation, practice it. So this was the question. Okay, where there is no any circular cross section product is coming out, because you know that extrusion process is used to produce the cross section shapes like circular, C shaped, I shaped, Z shaped cross section. All the cross section we can able to manufacture. Say like this also we can make extrusion final product cross section. It may be like this, it may be like this. Okay, it may be like this I shape, it was given here. Okay, or circular to common ही है, right? So all the shapes can be made by this extrusion process that you know. And here generally we are having habit to have the circular cross section always, but here they have given some different I section. Okay, I hope it is clear. I hope it is clear. Okay, shall I go for the next? Where is other people's? Why you are not calculating the things? Check it out whether 1.67 meganewton is correct or not. Dear students, please do the calculation. This was the question and we have solved this question. This was one more question which was again on the extrusion. See, apart from the normal things, we are trying to add the complexities, as here in this question we add the container wall friction. So we have to add that frictional stress, okay, because we have the value of this tau, it is given there. This question also little bit different than the regular practice, so we have taken it here. I hope it is clear. Yes, next. Now we will start with the questions related to the sheet metal working. Okay, fine. Take the question. A hexagonal blank of 20 mm side is to be produced hexagonal. Okay, 6 edges are there for the hexagon. Okay, now the sheet thickness is how much? 2 mm, and the shear strength is how much? So 6 sides for the hexagon, you know that. Thickness is how much? 2 mm, and the shear strength is how much? 140 megapascal. So they are simply asking the punch force. Come on dear students, wake up and be there in the chat box. There are only 2-3 people are just responding. Yes, tell me, you know that the maximum force F max in the sheet metal operation is equal to what? The sheared area into shear strength of the material. And you know that sheared area, how to calculate sheared area? That is perimeter into thickness into this tau s. So perimeter here is what? There is a hexagonal blank, isn't it? So 6 faces of how much side? 20 mm side. So what is perimeter? 6 into 20. Yes or no? So it will be 120 millimeter. Okay, so if I calculate this, F max is equal to 120 into thickness is how much? 2 into shear area, shear stress 140. How much it is? So it is 240 into 140, how much? It is 33600 Newton. So that will be 33.6 kilonewton. This is the F max in the sheet metal working. I hope it is clear. Giriraj, very good Giriraj. 33.6, 33.6. Yes, Giriraj, correct. 33.6. Absolutely correct. Absolutely correct. Yes, Sri Kumar, very good, very good, very good, very good. Priyanka Singh, very good, very good. Nice, nice. So shall we go for the next question? We'll go for the next question. See, now again in the same question, because it is a common data question, so data is given to you. Now the second bit of this question is given to you. The punch force required if the shear provided is equal to 2 mm on the punch. Now see, now they have provided the shear I, which is equal to 2 mm on the punch. Okay, of course this is punching operation, that is why shear is provided on the punch. Okay, and the penetration K they are giving as 40%. That is how much punch is penetrated into the sheet to cause the work done, isn't it? So you know that whenever the shear is provided, now the force is given as what? FB, which is the force when the shear is provided, which is equal to F max KT divided by KT plus I. KT plus I. So calculate FB is equal to F max. How much हमने calculate किया था? F max was 33600 into penetration 0.4 into thickness 2 mm divided by 0.4 into thickness 2 plus shear कितना provide कर रहे हैं हम? Shear is also 2 mm. Calculate. So into 0.8 divided by 2.8. It will be 9,600. How much it is coming? 9,600 Newton, which is equal to 9.6 kilonewton. How much you are getting? Please don't only sit there, solve it and respond it. Come on dear students. Yes, 9,600. Sri Kumar, absolutely correct. Priyanka, Giriraj, tell me the answer. Very good, Sri Ram, Sri Kumar. Very good, Priyanka. So are you getting it or not? Very easy. See, these are actually common data question. 2 marks for the F max and 2 marks for the FB. With the shear 2 marks, without shear 2 marks. So I hope this question is clear to you. Shall I go for the next? Shall I go for the next? Please be there. Okay. See it here. The minimum diameter of the hole which can be produced on the sheet of thickness 4 mm having the shear strength of 400 megapascal and crushing yield strength of the punch is 1600 megapascal and factor of safety is given 2. Okay. So you know that whenever the factor of safety is given, we are going to use that factor of safety on the crushing strength or the bearing strength of the punch, because that is the important valuable tool is there and we want to safeguard that. So definitely, so allowable crushing strength of the punch will be how much? Sigma allowable, it will be 1600 divided by 2 by providing the factor of safety, it will be 800 megapascal. Or sigma crushing, it will be 800 megapascal, isn't it? And to understand the force which is applied by the punch on the die, okay, the die is going to provide the equal and opposite reaction to the bottom of this punch, okay, on the cross section which is circular one on which it is acting. Okay, that force, this force F max and this reaction are going to be same, isn't it? So F max is what? Pi dt into shear strength of the sheet material, which is equal to this what? So area pi by 4, which is d square into sigma c, isn't it? So which is opposite, this is the opposite force given by the sheet onto the base of that punch, and we are interested to calculate the minimum diameter of the hole. Pi get cancel out, d get cancel out here. So 4t tau s is equal to, by application of the factor of 52, we are having the sigma c value is equal to d into 800. So tell me what is minimum diameter. So 4 times t is how much? 4 into shear strength 400 divided by this 800 is equal to d. So tell me how much it is. So d minimum is how much? It is equal to 8 millimeter. It is equal to 8 millimeter. Check it out whether you are getting 8 or not. How much you are getting? Are you there? Are you solving it or not? Yes, 8 mm. 8 mm you are getting. B, Bombay is the correct answer. B for Bombay. Bombay is correct answer. So how this 800? Because we have applied factor of safety 600 divided by 2. So where are you, Akhilesh? Tripathi Rakesh. Pranam Tripathi ji. Akhilesh Khadse, what is the answer? So you are getting here 8 mm, 8 mm, 8 mm. Very good. Next question. Next question is here. A cylindrical cup of 80 mm diameter, 250 mm height with a flange diameter of 150 mm is produced by using a deep drawing operation for a sheet of thickness 4 mm. Ultimate shear strength is 285 megapascal. The number of ears or earring defects produced around the circumference of the flange is. Calculate this thing. They are asking you to calculate the number of ears. Okay, 8 mm, very good, very good. Solve this next question. So cylindrical cup is there, 80 mm diameter. So diameter of the cup is what? 80 mm. Height is what? 250 mm. Okay, flange diameter is also given. Flange diameter, which is like this. (150 mm). This D1 is how much? 80 mm, and height is how much? 250 mm. Okay. So, and the thickness of the sheet? Thickness of the sheet is 4 mm. Ultimate shear strength is given 285, which is not required. We required here the yield strength of the material in the deep drawing operation. Okay, you can take it as 0.3 times of this 285. Right? But no need. Tell me what is the number, what are the number of ears that can be produced in this operation? So can anyone tell me the answer? So dear students, you know that if you go on calculating the number of ears, this is given by a very empirical or experimental, actually, these results. 2 to the power n, where n is the integer which is depend upon the material. Okay, the whether you are having the lubrications, okay, the bending, these all are overcome in this integer n. Okay, So definitely n is equal to what? Number of years which are equal to 2 to the power n. So if you just look at the options, okay, so which is the option which is very fit to the 2 to the power n? 2 to the power n. These are nothing but the number of years, where n, it is an integer, depend upon the material, then the friction and bending, on these things this value of n is depend. So please tell me what is the correct answer. What is the correct answer now? So only in the amongst the option A, B, C and D, you will see only this option C, which is in the very good fitted in this 2 to the power n. Why C? 2 to the power n only. It is only C which is going to fit very nicely. So how much? If you have 2 to the power 6, yes or no? 2 to the power 6 is how much? 64. 2 by 2 by 2 by 2. So 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32 and 32s are 64. That is correct. 64. 64 is only correct answer. No need to go and look here and there what is given and what is not given. Only formula is this only, 2 to the power n. Okay. Now suppose if anybody asks you to calculate the blank size for this, calculate the blank size. Calculate the blank size. For this, you know, whenever the flange is there, okay, so this is D1, this is D2, and the height is given to you. This is the height. Calculate the blank size calculation for this particular data where the flange is there on the cup. So how it is calculated? One side surface area of blank is equal to one side surface area of the product. Product is what? Product is our cup. One side surface area of cup. Tell me, that is this pi by 4. This d square is equal to, this is pi by 4 d1 square. This is one side. This is the d1 square plus pi d1h, and plus when you look at from the top you will get this flange. That surface area will be pi by 4 this d2 square minus d1 square, isn't it? So ultimately d is what? You will be getting d2 square plus 4 d1h. Corner radius is not given, so no need to worry about that to check the d by r ratio. So d2 is how much? Flange diameter 150 whole square plus 4 into d1 is how much? 80 into height is how much? Height of the curve 250. Tell me what is the blank size? D will be how much? Please write here answer. Please tell me, calculate this and tell me the answer. So it is so from my side it is coming as 320 millimeter. 320 millimeter of this blank size. Please check it out whether it is correct or not. Yes, Sri Kumar, very good. 320.1, very good, excellent. So very good. Anyone is there? Anyone else who can tell me the answer? Or not interested? Yes, Priyanka, very good. 320.15, that is correct, absolutely correct. Now बताओ यहाँ पे, चलो दूसरा क्वेश्चन ले लो. Okay, an octagonal hole of side 60 mm and thickness 3 mm is to be produced by using the piercing operation. The ultimate shear strength of the sheet material is 315 megapascal. if the energy consumed for producing the octagonal hole is 544 joule, then they are asking what is the percentage of penetration. So dear students, when you talk about the work done with the shear and work done without shear, that is a very important assumption in deep drawing operation, in the sheet metal working, that we are assuming that this work done is equal to same, isn't it? So work done or energy is what? In case of when there is no any shear is provided, it will be F max into KT, and when there is shear is provided, it will be what? This FB will be there and into KT plus I. I is what? Additional distance we have to travel for the punch, that is nothing but KT plus I, total distance. So work done is how much here? Directly given, that is 544 joule. So 544, it is in Newton meter. Okay, it is joule Newton meter, which is equal to F max. F max will be how much for this octagonal hole? So sides are how many? 8 sides. So 8 multiplied by 60. So it will be 480 mm. That will be what? Perimeter of this octagonal hole, isn't it? Thickness is how much? 3 mm. And shear strength is how much? 315 megapascal. So calculate first F max. F max is what? Perimeter into thickness into shear strength. Perimeter 480 into thickness 3 into shear strength 315. Tell me how much F max? 480 by 3 by 315. So it will be 453,600 Newton. 453,600 Newton, isn't it? And when you calculate this work done, okay Sri Kumar, work done is equal to what? That is F max into KT. F max into KT. So work done is 544 into 10 to the power 3. I am writing in Newton millimeter. Okay, because it is Newton meter is there in joules, is equal to F max is how much? 453.6 into 10 to the power 3 Newton into K is how much? Unknown, and thickness is how much? 3. So 10 to the power 3, 10 to the power 3 cancel out. So 544 divided by 453 divided by 3, that will be K, which is nothing but 0.40, which is nothing but in percentage it is 40%. 40%. Very nice, Priyanka. So yes, option C for Calcutta, C for Chennai. Very good, C is correct. Answer C is correct. Very good, C is correct. Yes. So what is penetration? They are asking penetration K value. They are asking penetration K is equal to what? 40%. 40% you are getting. I hope it is clear. Yes, take this next question. So dear students, from the tomorrow session we are going to discuss the questions on the metal cutting. So here we are ending this metal forming and sheet metal working. In the tomorrow session we will be discussing the questions on metal cutting, which will be having again 2 parts. The tomorrow and day after tomorrow we are going to discuss for this metal cutting, right? So be there. So increase some numbers there. Definitely we are doing it for you only. So of course we want some response from your side also. I hope you are getting this Things clear how to solve these questions on the sheet metal working? Now dear students, see what they are asking. They are asking R minimum is how much? R minimum is question mark. When R minimum they are asking? So see here, sheet of thickness of sheet is given 5 millimeter. Okay, percentage reduction in area at the time of fracture in the tensile strength testing or tensile testing. Okay, what A is given 25%. So A is what? This is the percentage reduction in area at the time of fracture in the tensile testing. It is given as A, which is equal to 25%. Okay, and they are asking, yes, Sri Kumar, 40% is correct. And they are asking what is the minimum radius to which this sheet can be bent. So you know that R minimum, how to calculate? R minimum is equal to T into bracket 50 by A minus 1. This is the standard formula that we are having. So T is how much? 5 into bracket 50 divided by A is how much? 25% minus 1. It will be how much? 5 into bracket 2, 25 2s are 50, 2 minus 1, that is nothing but 5. R minimum is nothing but 5 millimeter, not minute. R minimum, you got it as R minimum, it is nothing but 5 millimeter. I hope it is clear. So C is the correct answer. C is the correct answer. Yes, Giriraj, correct, absolutely correct. C is the correct answer. Tell me the answer for this question. Come on. How many of you there? Please answer me this question. A drawing board clip is produced by using the following bending methods. U bending, V bending, H bending. Write the above method in the increasing order of their force required for producing this clip. Dear students, as you know that there are typically basic 3 drawing methods we are having: U bending, V bending and H bending. V bending is also known as the air bending. And you know very well that the ratio of forces for U as to say V as to H bending is nothing but equal to 2 as to 1 as to 0.5. That means the maximum force always required in the U bending at the top, then V bending at the second place and H bending at the lowest. Okay. So of course U bending will be at position number 1, V bending at second and H bending as number 3. So 1, 2, 3 increasing order. They are saying the increasing order. So lowest सबसे कहाँ पे लिखेगा? H bending, then for V bending and then for U bending. 3, 2, 1, 3, 2, 1, 3, 2, 1. That is D. Delhi is the correct answer. D. Delhi is the correct answer. I hope it is clear. D. Delhi is the correct answer. So they are asking increasing order of force, increasing order of their force, increasing order, Priyanka. They are saying increasing order. Take this question for homework. Okay, take this question for the homework. Right? Can you solve this question? So blank is given like this. So of course there is only thing is that you need to calculate the perimeter first. For that we require this length. This length is not given, but yes, this is okay. 60 minus 30, it is 30, and 70 minus 40, it is 30. So it is if you take sine of 45, Okay, it will be equal to 30 divided by this, say, unknown x. So x is equal to 30 divided by sine of 40, which is equal to 30 root 2, isn't it? And just go for calculation of the perimeter, that is 60 plus 40, 100, 170 plus 30, 200 plus 30 root 2. Okay, this will be the perimeter. And now just go for calculation. Perimeter into thickness into tau. Perimeter 200 plus 30 root 2 into thickness 2 into shear strength 350. Tell me the value. This is the in kilonewton. Very easy, very easy. Okay, so dear students, like that you can have the questions on the, see again, this is again very simple question, dear students. In deep drawing, the wrinkling defect is reduced by, in deep drawing the wrinkling defect is reduced by, okay, wrinkling is a defect, we can reduce by the provision of the blank holding force, which is generally one third of the force in the drawing operation. Then you can go for the ironing effect. Okay, ironing effect, the provision of the clearance slightly less than the thickness of the sheet, right? Then also you can have the provision of what? Draw bits, right? So all these things you can do. Then providing clearance between punch and die greater than the sheet thickness, we are not doing that. So what we are doing, we are not avoiding this ironing effect, we are causing this ironing effect. Okay, using blank holding force, that is correct. Using draw bits, that is correct. So 1 and 3 are correct. 1 and 3, option B is correct. B, Bombay is correct, right? So you know very well how to minimize this wrinkling defect. Okay, by provision of the blank holding force BHF, by provision of the draw bits, by provision of the ironing effect, the provision of the clearance slightly less than the thickness of the sheet, that is the ironing. So all these things, this 1 and 3 only are correct, 2 and 4 are actually the wrong statements. Okay, then you know that partially drawn curve in the bottom of the punch zone in partial deep drawing curve with the blank holding force, actually at the bottom, if you look at, okay, and if you are taking a partially drawn curve, so of course this is the flange portion, say this is the portion number 1, this is flange portion, this is the deformation zone 3, and this is the flange portion 3. Okay, so in deformation zone, no doubt the stresses which are going to induce, that is the pure tensile stress only. Okay, at the bottom generally no stresses. Okay, but when you apply in the blank holding force BHF, there are slightly tensile stresses only. There are slightly very small tensile stresses only when with the blank holding force. Without blank holding force, no any stress. Okay, but yes, with the blank holding at the bottom of the punch at position 1, definitely the little amount of, or very small, the little amount of tensile stress only, right? So this is how we can have the various stresses. Of course, in the zone 2, that is in the deformation zone, whether it is a BHF or there is no BHF, the forces or the stresses which are induced there are the pure tensile only. Okay, so now just go and read what are the stresses when the blank holding force is there or not there at the flange portion, which are the stresses are going to induce in partially drawn curve, right? So dear students, so see here, this Gradeup GATE 2021 is very ideal course. You know, it is very ideal course for making the revision of the entire GATE syllabus. Rank Up is very ideal course to improvise the score or to improve the rank in the GATE, right? And dear student, this Vision 2022 is very ideal course for the second and third year students who want to join, who are going to write the examination in 2022. GATE and ESE, right? So just go through the details. Okay, any query you can contact on this number. These are our staff faculties from the Gradeup. These are our achievers in top 100, 60 plus achievers from the Gradeup. So this is the pricing, dear students. Any queries you can go and contact on this number. In the tomorrow's session at again 7 p.m. we'll be talking or discussing about the metal cutting part 1. We'll solve the questions numericals on metal cutting part 1. So dear student, do follow me on the Gradeup app. Do follow me on the Gradeup app. There are also the various free series are running. Please join them and take the advantage. So tomorrow we will meet again once again at 7 p.m. Thank you so much for joining the session and be there tomorrow also in huge numbers. Thank you so much. Bye bye. Good night.